Okay, so let's go over that trick again that I just showed you about adding and subtracting. So it works in a lot of different situations. So here's x squared over x squared plus 1. So I want to match the denominator, correct? So I want to add 1 and subtract 1. And I'm going to put the x squared plus 1 first, so that when I gather that together, x squared plus 1 over x squared plus 1, right, that will turn into 1, and then I'm going to subtract off the 1 over the x squared plus 1. So I separate the integral around the subtraction sign, so this gives me 1, and then this you recognize as arctangent. So I get x minus, arctangent of x. Lost the x there, didn't I? Arctangent of x. Okay, so let's try with this one. So I could say I want to match the denominator. So I want to do x plus 2 minus 2, because that doesn't change the problem, right? And so then I'm going to invest the time to split it up. So this and this, right? So x plus 2 over x plus 2 minus 2 over x plus 2. And so then this gives me 1 minus 2 over x plus 2. And so then this is x, and then you know, this is just the same one we just did, right? Sorry, I should have given you a different one here. So du is dx, so I would get minus 2 times the integral of 1 over u du, right? So I took the integral of this one, and doing this one I needed u substitution. So I get x minus 2 times ln of u, and then go put the x's back in. So take the time, keep yourself organized, right? Keep all of the line written over and over again so you don't lose part of the problem. So here's a harder one. So here's 2x plus 1. So I want the denominator to, I want the numerator to match the denominator. So I want to add 1 and subtract 1 so that it matches the 2x plus 1. So then I'm going to break it up. So I get 2x plus 1 over 2x plus 1 minus 1 over 2x plus 1. Okay, so this gives me 1 minus 1 over 2x plus 1 dx. Okay, so this one I'm going to need u substitution on. This one is just 1, right? Integral of 1 is just x. And so here I'm going to do a little u substitution. Let u equal 2x plus 1. du is 2x. So minus 1/2 1 over u du. Take the antiderivative, ln is the absolute value of u, then take the time to put the x's back in. Make sure you're putting the absolute value bars around the inside of the ln, correct? All right, so another way to take care of this is long division. Okay, so it's just something we need to review because it's going to be coming up. So it will be necessary often, not all the time, but often, to do long division if the degree of the numerator is not smaller than the degree of the denominator. So here's an example right here. So this is x cubed in the numerator, x in the denominator. So there's no trig functions, there's no e's, it's just polynomial divided by polynomial. So let's go do our long division. So it's probably been a while. So x cubed plus 1 is what we put in the box, and the x minus 1 is the divisor that we put out here. So remember, we have to think, what can I multiply by x to get x cubed? So that's where it's x squared. Right? X squared times x gives me x cubed. Then I also multiply the x squared times the negative 1, so that gives me a negative x squared. And I'm just writing it off to the side because I'm reminding myself, oh yeah, I have to make sure I gather like terms, right? So I'm going to subtract. So x cubed minus x cubed gives me a 0. There's no x squared term up here, but I'm going to take the opposite of this negative x squared term, so I'll get a positive x squared, and then this 1 will subtract. There's no term here, so it's like saying 1 subtract 0, so that gives me a positive 1. All right, can I take and multiply by something times something times x to get me x squared? Sure can. So it's a positive x. So positive x times x gives me x squared. Positive x times negative 1 gives me a negative x. And so now I subtract. X squared minus x squared is 0. There's no x term up here, so the opposite of this negative x term is an x, and then this 1 carries down. And so now I do it again. And I want to say, okay, I'm going to have a positive 1 times the x and the minus 1, and then I'm going to subtract. So x minus x is 0. So here I have a 1 plus a 1, so that's a 2. So this is my remainder, right? So what that means is this fraction that's inside the integral turns into this plus, and how you say remainder is 2 over the divisor. So all of that. So this fraction turns into this. And this is better because now I can take the antiderivative of this. So this gives me x cubed over 3, x squared over 2, x, and then this right here, little quick easy u substitution. So I see that this is plus 2 times 1 over u du. So let's just carry everything else along. Plus 2 times ln of u, and I'm just going to take liberties and put the u back in right away. Okay, so let's just make sure you know how to do long division. So it's x to the 4th that goes in the box, and then I'm going to have x minus 1 as my divisor out here. So it's x cubed, and I'm going to multiply times x to get x to the 4th, right? And then this x cubed times this negative 1, and then you subtract. So the x to the 4ths are gone, and here I'm left with a positive x cubed. So now I'm looking at the next term, so it's x squared that I would multiply times x to get x cubed. I'm carrying through the negative 1 times the x squared, and then again I'm going to subtract, so these are gone, and I'll get a positive x squared. So then I'm going to have a plus x, so I get an x squared minus an x, subtract, I'll get a positive x, and I think I'm almost at the last. Let's move it up a bit here, almost at the last. So I'm going to have a positive 1, so I'll get x minus 1. And again, I subtract, so I'm left with a positive 1. So what this fraction here turns into is x cubed plus x squared plus x plus 1 plus the remainder of 1 over x minus 1, all dx'd. So x to the 4th over 4, x cubed over 3, x squared over 2, plus x, and then this is an easy ln. Hopefully you're getting comfortable with that, plus a c. Okay, one more. Again, this numerator degree is larger than the denominator degree, so that's how I know long division is going to come into play. So x squared plus 4. Okay, so it's going to be x times x squared gives me x cubed, and this gives me a positive 4x, and then I subtract. So this will be a negative 4x, and then plus a 4 that will come down. And that's it, right? Okay, so because there's nothing I can multiply times x squared to get a 4x. So I don't go into fractions, I just leave it like that. So this fraction turns into x plus a negative 4x plus a 4 over the x squared plus 4 dx. Okay, so big star by this one. You're going to encounter this kind of fraction in just a couple of sections. So I want to go over some details here. So you see this negative? Be careful that you do not put it here, because this negative just goes on this 4. If you pull the negative down in front, so let me just write wrong. If you pull the negative in front and you did this, what this means is this negative is really distributed to both of those. That's not true, is it? This negative does not go to this 4, so that would be an incorrect thing to do. Okay, so what we do need to do is not a very profound thing, but a very necessary, is I need to separate this fraction because I cannot do this integral, right? And let me just write it one more time, just so you can see. So you're thinking, oh, maybe I'll do a u substitution. So if you did u equal the denominator, I get 2x dx. X, yeah, there's an x there, but you've got this positive 4. So this u substitution will not work. Okay, so now what I'm going to say, this is a big deal, is you want to separate this fraction around the addition in the numerator. So I've got this x, and then I have a negative 4x over x squared plus 4, plus a 4 over an x squared plus 4, all dx. Okay, so let me make some room for myself up here. You've already got this written down. Okay, so this, let me pull it up here. So I have integral of x minus 4x over x squared plus 4 plus 4 over x squared, plus 4. So all very different problems to solve. This is just easy, take the antiderivative, right? This one here can use this u substitution, right? If I let u equal the denominator, so let me get rid of my x here. So if I let u equal x squared plus 4, I get du is 2x dx. So I get so I can say, okay, let's pull the 2 out, let's pull the negative 4 out. So I have negative 4 over 2, just going really slow so you see it, 1 over u du. Right, putting the u in for the denominator. This 4 I pulled outside, this 2 comes outside. So this is integral of 1 over u. This one is something that you know. You remember this is the arctangent. So carrying this 4 along, I know if it has 4 here, the a is 2. So I have 1 over 2 arctangent of x over 2. Now I can finally finish it off. X squared over 2 minus 2 ln of u. Let me put the u back in. And then plus a 2 arctangent of x over 2 plus c. Wow, that was tough. A lot of work there. Very important stuff here.